Hello everyone, welcome to Form 3 Mathematics. This is the part 1 video for chapter 6, Angles and Tangents of Circles. So in this chapter 6.1, we are going to look at angle at the circumference and the central angle subtended by an arc. So before you get confused by the title here, we try to do a bit of a revision regarding the terminologies that we are going to use regarding circles that you have learned before. So here we have a circle. So this dot in the center of the circle, we call this the center of a circle. And this line here, the outline of the circle, we call this the circumference. Then we have a line which connects the center of the circle to the circumference at a point here. So we call this a radius. Next, we have a straight line from one point of the circle to another point of the circle passing through the center of the circle. This line here, we call this a diameter. This must be a straight line. And we have another line where one point touches the circumference and another point touches the circumference, like for example this, but does not pass through the center of the circle. Other examples for this line here is like for example this. Okay, so this we call this a chord. Now this is a chord. This is a chord. Now if we have two radius connected like this, and from this point along this circumference, along this part of circumference until this point here, which is denoted by the blue line here, this we call this a minor arc. It is a minor arc because it is the smaller part compared to the bigger side here, which is represented by the green line. Okay, this green line here is what we call as a major arc. And then the area surrounded by these two radius and the minor arc, which is painted blue here, this area we call this minor sector. So I think you can guess that this area, we call this the green colored sector, we call this the major sector. So this is a very quick revision on the terminologies that you have learned. We continue. Now, angles at the circumference of a circle. So what is the angles at the circumference? Okay, so let's say you have a circle here, and then you draw a line, which is called a chord, and we connect another chord here, and we label this point here as A, this point here B, this point here C. Now this angle is called as angle ABC, written as this angle ABC. And then from the point A to point C here, okay, this line, along this line, we call this an arc, the minor arc, and we can also write this as arc AC. It's a minor arc of AC, which is denoted by the blue line, the arc AC. So when we want to describe this angle, we can say that angle ABC, this angle here, which is angle ABC, is the angle at the circumference of the circle subtended by the arc AC. So this is how we describe this angle in this situation. Angle ABC is the angle at the circumference of the circle subtended by the arc AC. We try more examples. So now we have another two chords here, and then which forms an angle. So this angle here is called angle PQR. Okay, PQR. And this line from point P to point R, this line here, we call this an arc PR, minor arc PR. So angle PQR is the angle at the circumference of the circle subtended by the minor arc PR. This is how we use when we want to describe angles at the circumference. How about this? Can you describe the angles ABC? Okay, so angle ABC is the angle at the circumference of a circle subtended by the arc, by the minor arc AC. Okay, so ABC is the angle at the circumference of the circle subtended by the minor arc AC. Next example, PQR, the angle PQR is an angle at the circumference subtended by this arc. This time, this is a big arc compared to here. So this is a major arc, PR. Okay, so angle PQR is the angle at the circumference of the circle subtended by the major arc P R. Angle ABC, this angle here, is the angle at the circumference of the circle subtended by this arc. So this arc here is arc AC. This is a big arc, so it is a major arc AC. So the answer here, the angle ABC is the angle at the circumference of the circle subtended by the major arc AC. This is how you describe the angles at the circumference, which is subtended by the certain arc. And now we're done with the basics. We go to the next part. So before we look at the conclusion of next part, we try to look at this example. Here you are given a circle. You have an angle 30 degrees here, angle ABC, which is an angle at the circumference subtended by the minor arc AC. If I draw another line starting with point A to here, and I draw another chord here starting from point C here, and I label this as point D. And when I measure this angle here, ADC, this angle, I will find that this angle has the same value as this angle, which is 30 degrees. I measure this with a protractor. Then I try again. I draw another line, a green line here, starting from point A, and I draw another line starting from point C. And this touches another point on the circumference. So now I label this E and measure this angle here. I will find that it is also 30 degrees. So what conclusion can we get from here? Angles at the circumference subtended by the same arc are equal. Okay, so these three angles subtended by the same arc, which is arc AC. So any angles you form subtended by the same arc AC, they will have the same values. They are equal. This is the first property, and it is very important that you need to know. So we try to look at the examples. How can we use these properties? Before that, you need to note that for this angle here, this is not the angle at the circumference because this point does not touches the circumference. Thus, this angle does not equals to this angle. They are not equal. And one more is, if the point here is outside the circle, it's not on the circumference, it's outside here, this angle does not equals to this angle. So it must lies on any point on the circumference. Now, we look at an example. Given angle ADC is 25, angle ADC, the angles formed by the blue lines is 25. State the value of ABC, which is this, and angles AEC. AEC is this angle. So if you are confused with this, whenever an angle is written in this form, you look at the center point. D means the angle is formed at this point. Okay, ABC means the angle is formed at the vertex B, so this point. AEC means the angle is formed at E, which is this angle. Of course, if you apply the properties, since these three angles here are angles at the circumference, that touches the circumference, and they are subtended by the same minor arc. This angle, and this angle subtended by the same minor arc AC. Hence, this angle, and this angle here are equal. Since this is 25, angle ABC 25, angle AEC also 25. Example number 2, we have a slightly harder question. Calculate the value of the angle X. So we want to find X now. Okay, so you are given 35 and 25, which is angles at the circumference. So you know you need to use the information here. Okay, so now we take this the same diagram here. I draw this line yellow. I color this line yellow and this line so that you can see the difference here. Okay, the yellow line and the black line forms angles here and here, which is angles at the circumference of the circle subtended by the same arc. Okay, for the yellow line and the black line, they form angles subtended by the same arc here, the blue arc. Hence, we can say that these angles here is equal to this angle. So this angle is also 25 because this angle and this angle, they are subtended by the same blue colored line arc. So now we look at this pink triangle, pink line triangle. We learned before that the total angles in a triangle is 180. So if you want to find this angle, we take 180 minus 35 minus 25, you can find this angle. So 180 minus 35 minus 25 is 120. So we know that here is 120. And since this is a straight line, if you want to find x, you take 180 minus 120 here. Okay, so 180 minus this, you can find x. So 180 minus 120 is 60. Example number 3. Given the diagram where chord AD equals DF, okay, so AD equals DF, angle ABF equals to 32. Remember, ABF means you look at the B here, huh? So ABF angles here, this is 32. CAD, angle CAD, D is here, sorry. CAD is 15, so it means this here is 15. Determine the values of all these angles. So since chord AD equals DF, so AD equals DF, so I note down here. Okay, AD equals DF. So now we are going to use this information, this diagram here, to find all these angles. So the first one, AEF. AEF. So the angle is here. Okay, so you can see that AEF is the angle at the circumference of a circle subtended by the arc AF, this arc here. So you ignore the other lines. You only look at AEF and this arc. And then from the same arc, actually this is another angle here subtended by the same arc AF, which is the angle ABF, 32. So if ABF and AEF subtended by the same arc means this angle here equals to this angle. This is the first property that we learned. Hence, we say that angles AEF is 32 degrees. Next, question B. ADF is subtended. So the angle ADF actually is subtended by the same arc again, AF. So since ABF is 32 here, and this ADF subtended by the same arc, means this is also 32. So angle ADF is also 32. C. CFD. Okay, this time is this angle here. Okay, CFD. CFD is this angle here. So you can see that this angle is the angle at the circumference of a circle subtended by the arc CD. Okay, so this angle is subtended by this arc CD. And if we look at this side, there is another angle, which is this angle here. Okay, this angle is also subtended by the same arc CD. Okay, because of this line and this line, same arc CD. Hence, this angle here equals this angle, which is also 15. Hence, CFD is also 15. So now we go to question D, CAF. Okay, so CAF means we want to find 15 degrees here plus this angle. Okay, so this angle is DAF. So we want to find this angle plus 15, which is 15 plus angle DAF. Okay, so if we look at angle DAF, this is an angle from this orange triangle. DAF is from this triangle. And notice that this line and this line are the same. Hence, this is an isosceles triangle, meaning that the base angle here, this DAF, and this DFA, this angle here, they are equal, they are the same. if we know this angle, we can find the two angles. Previously, in a previous question, we already find this angle, which is equals to 32. Hence, to find these two angles, we get 180 minus 32 divide by this 2, divide by 2. So 180 because the total angles here is 180 minus 32 divide by 2 because this 2 is the same. So divide by 2, you get the answer is 89. So we move on to the next part where we learn the next property. So now we have a circle with an angle 25 degrees subtended, which is an angle at the circumference of the circle subtended by the arc PR, the minor arc PR, 3 centimeters. So now if we draw another line here, and this line, which forms an angle. So if we measure this arc here, we measure the arc which is 3 centimeter. Then when we measure these angles here, when we measure this angle, we find that it is also 25, same angles as the angles PQR. Okay, if we try again, now we try to draw another, form another angles with the arc which is the same as a 3 centimeter here, 3 centimeter here. Then we try to measure the angles here. We find that this is also 25. So from these two examples here, we can conclude that angles at the circumference subtended by arcs of the same length are equal. Okay, so when this arc here and this arc here has the same length, 3 centimeter, 3 centimeter, the angles subtended are the same. This arc, 3 centimeter, this arc, when they have the same length, the angles subtended by these two arcs, they will have the same value. They are equal. We try examples. Okay, so example number 1, determine the value of x. Okay, so x, the angle x is subtended by this arc, and the length of this arc is 5. And then when we have another arc, and then we have another angles here, subtended by arc which is also 5 centimeter. The length of the arc is 5 centimeter. So when the length of the arc is the same, the angles are the same. So x is 20 degrees. Example number 2. Given arc AC, so from A to C equals to B to D. So if this AC and BD are the same, the angles subtended by arc of the same length will be the same. Okay, so this angle is subtended by AC. This angle is subtended by BD. AC equal length to BD. They have the same length. Means this angle is equals to this angle. They are the same. So x is 27. Try a few more examples here. Okay, so this angle is 30 degrees. This angle is also 30 degrees. Okay, so this time we start with the angles. When the angles subtended by the arc are equal, this angle and this angle are equal, this means that the arc length here is equals to this, the arc length, because the angle is the same. So the arc length of this equals to arc length of this. Hence x is 4.5 centimeters. So this is the first two properties you're going to learn regarding the angles at the circumference. So I'll see you in the next video where we learn more properties of angles at the circumference. That's all. Thank you, everyone.